Hello ladies and gentlemen, this is Mr. EDK. Today I'm going to be teaching you guys how to determine the difference between a linear and exponential function by looking at a graph. In order to do that, I have already created a table for both a linear and an exponential, but I haven't shown you the graph yet. We are actually going to make the graph and then discuss the differences between them. So the first one we're going to look at is the linear. And from this table, we're going to get 1, 2, 3, 4, 5 points. And let's go ahead and see those graphed really quickly. So the first point is -2, -5. I've counted it out over here, -1, -2, and then going down 2, 4, 6, and 5 is halfway in between. So this is my first point. I'm going to follow the table to make the rest of my graph now. And I'm going to take those 5 points and I'm going to connect them with a straight line. And that right there is a linear graph. What, on the other hand, would an exponential graph look like? Well, this is our table. I'm just going to show you guys really quickly as a recap on why this is exponential. To get from one term to the next term, in terms of our output, we are multiplying the output values by 2 each time. So this is times 2, times 2, times 2, and times 2. So it follows the pattern of exponential. So let's take a look at the graph. My first point is -1, 1.5. I'm counting my y-axis by 3s. 3, 6, 9, 12. 1.5 is halfway between 0 and 3. So my first point is going to be here. And I'm going to follow the table to make the remaining 4 points. What I'm going to do now, ladies and gentlemen, is I'm going to connect those 5 points and see what kind of shape is created from them. Now, as we get farther and farther to the left on the graph, it's going to become more and more difficult to graph the points. But what's going to happen is these points are going to become slowly but surely get closer and closer and closer to the x-axis, but never actually touch it, because we're going to keep getting smaller and smaller by cutting it in half, going in the negative direction. On the other hand, this is going to continue to go upwards and it's going to continue to curve. When I look at these graphs, ladies and gentlemen, it is very clear what some of the differences are. To really quickly point out what I see, a linear is literally a straight line, and you can see that in the name for linear. In the word linear, you have the word line within it, and this is a straight line. Exponential, on the other hand, it curves, and it's kind of this J shape almost. It looks like this, and it always goes like that. It doesn't go back up, it continues to go downwards, but it does become flat here, while this continues to go upwards forever. And if we were to keep doubling this, 24 then becomes 48, 48 becomes 96, 96 becomes 192, and as you can tell, the output values get larger and larger and larger faster as we increase by the same 1 unit in my input values. Let's go ahead and write down what an exponential or a linear graph might look like. A linear graph is a straight line. And it might look like this, or like that, or even horizontal, but it goes on forever. An exponential graph is J-shaped. And it's going to look like this, and it becomes flat in this direction, and it goes up forever towards the right. Or the other option, which we haven't seen yet, is one that looks like this. And again, as we get closer and closer in one direction, it's going to become flat in this direction. It's going to become more and more horizontal. And that is what the graphs are going to look like. So when you're looking at a graph, if it's J-shaped, whether it's normal J or backwards J, it's going to be exponential. If it's a straight line, it's linear. If it's anything else, it would fall under the neither category. So things that would fall under the neither category would be some graphs that we've seen already. Absolute values are neither. Parabolas are neither. Radicals are neither. And other types of shapes that you've never heard of yet, so such as the sine curve or a logarithm. Be careful with a logarithm, because a logarithm looks very similar to exponential because it becomes vertical here on this side. It becomes flat over here. Not up here, it becomes flat over here. Thank you for watching my video, ladies and gentlemen. I hope this was informative and helps you out with your future work. Take care and stay healthy. See you next time.